Okay, relations review. So I thought I'd go through this with you in case you want to check how the answers came about. We'll post the PDF of these answers, but this is the how. Identify whether the following represents discrete or continuous data. Height of the tide as a function of time will be continuous because the height of the tide will go through all possible values of height. It doesn't jump all of a sudden. It's at 1 second it's at this height, and the next second it's a meter higher. The cost of a pizza as a function of the number of toppings. Number of toppings is discrete. Okay, you can't have 1.5 toppings, although I suppose you could do half pepperoni or something. A relation is represented by the arrow diagram shown. Represent the relation as a set of ordered pairs. Alright, so important things notation-wise, right? Set builder notation, the brace bracket to indicate a set. 2 goes with 5. 3, and the ordered pairs themselves are enclosed in brackets with a comma in between to separate them. And it's very important that you always put ordered pairs in brackets. That tends to be a problem for some people. 4 goes with 5, and 5 with 15. Close that bracket, and that closes off our set. Set the brace brackets to indicate the set. Write the domain and the range. Domain. This also is a set, but it's just the numbers that are in the first oval. And the range, just the numbers that are in the second oval. And we don't repeat, right? Since we're looking at the ordered pairs, if we were doing a domain and range from ordered pairs, we wouldn't say 5, 10, 5, 15. You know, it's much easier to do domain and range from an arrow diagram since everything's listed and nothing is repeated. Explain why the relation is a function. Each element of the domain is associated with exactly one element of the range. Change the arrow diagram so it's no longer a function. Okay, so we do this. And it's no longer a function since the element 5 will now be associated with 2 elements of the range. Moving on. A relation is represented by the table of values shown. State the independent and the dependent variables. So the independent is number of books, and the cost depends on the number of books. Is this relation a function? Each element of the domain goes to only one element of the range, so yes. Each number of books is associated with only one cost. Is relation discrete or continuous? We'll go with discrete. Well, you can only have whole numbers of books. State whether or not the relation is linear. Okay, so if we go up by 5, we go up by 35, up by 5, up by 35, up by 5, up by 35. Yes, comma. Each increase of 5 books results, I gotta get a grip on this pen, in a cost increase of $35. The table values has been extended. Complete the table. Determine the rate of change. Well, let's take this to 25, and this will add on 35 to 205, and this would be 0, and then the cost could be 30. And in this case, just some fixed cost, and then depending on the number of books, there's a per book charge. Determine the rate of change. So the rate of change is the change in the dependent variable. So we're going up by $35 for a $5 increase in books. That's change in dependent, which is 7. And in units, that's $7 per book. So this could be some kind of shipping charge or something like that. So the rate of change represents $7 per book. Write an equation in function notation that relates the cost. So cost as a function of number of books is 30 plus 7n. So there's that fixed cost of 30 plus 7n. Now, if you're trying a function, try it out. If I put a 5 in there, that'll be 35 plus 30 is 65. If I put a 10 in there, 70 plus 30 is 100. If I put a 20, 140 plus 30 is 170. So that I can see that this does in fact work. And that's a check that you should run while you're writing a test. Determine the value of C of 60. Okay, math is a formula. It's a substitution, so wherever we see n plus 7 times 60, let's go over here, C of 60 is equal to 30 plus 420, C of 60 is equal to 450. What does C of 60 mean? Well, this is the cost for a number of books. Cost of C of n. It's the cost of 60 books. Determine the value of C of n, or sorry, of n if C of n is 1325. So like, again, we start with our formula. Every time you do something that has a formula, write the formula down. Every single time you do anything in math that has anything to do with the formula, write the formula down. Then we substitute. So we know C of n is 1325. That's equal to 30 plus 7n. We are going to subtract 30 from both sides. This will be 1295 is equal to 7n. And we will divide both sides by 7, so n, 1, 7, 59, 8, 56, 3, 5, 7. So n is 187. And this says the cost of 187 books is $1,325. Or really says if the cost of the books is $1,325, then there are 187 books. If f of x equals 9x plus 3, then determine f of negative 4 is equal to 9. I can see the formula there, right? So I'm just going to go with that. Times negative 4. So what we're doing in function notation is the x is now being replaced by negative 4 wherever there is an x. So negative 36 plus 3, or negative 33. Now here I can't see the function anymore. It's not handy right above, so I'm going to rewrite it. F of x is negative 27. That's 9x plus 3. We will subtract 3 from both sides. Negative 30 is 9x. X will be negative 30 divided by 9. Which reduces since 3 goes into that, so negative 10 thirds. And that is the value of x. You can check this by plugging negative 10 thirds into here, multiplying it out, and working out f of x. Similarly, you can plug negative 33 in here and then work back your value to get x is negative 4. A relation is represented by a graph. Use the graph to state the value of f of negative 2. So we have to find when x is negative 2, what's y? I'm going to say that it's negative 6. So there's no formula to show here. We can simply look at the graph. What is the value of x if f of x equals 4? So think of that as we draw a vertical line on 4, right? F of x equals 4 is another way of saying y is equal to 4. So x is equal to 1. Oh, sorry, negative 1. X is negative 1, positive 1, and x is equal to 3. So we could say negative 1, 1, 3. So x is equal to the following set of numbers. Remember, this is brace brackets, indicates a set, not an ordered pair or ordered triple. The point x negative 13 lies on the graph. Determine the value of x. Well, a point on a graph is an xy. So we know that negative 13 is 5x plus 2. So that's my formula. Now I'm substituting. So it's right underneath. Subtract negative 15 is 5x, and x is negative 3. And you need to show that work. That's determine the value of x. Simply stating, just writing down here, x is negative 3 will get you no marks. State the domain and range, or whether or not the relation is a function. Use appropriate variables. Okay, so if we don't see variables on the axes, then we'll use x and y. So here, x is greater than or equal to negative 4. Y belongs to the reals, since it goes up forever and down forever, and this is not a function. And I kicked off my pen. Give me back a pen. No, right? Since it fails the vertical line test. I draw a vertical line. The point 2, the domain value 2, has two different, I should have used 4. 4 has two different values associated with it, right? 4 negative 1 and 4 3. Domain. We don't have arrows, but I know this kind of function, and it really should have arrows. Without arrows, it would look like this. Negative 7 less than or equal to x less than or equal to 6.5, let's say. Truly, this is x belongs to the reals. The range, well, what's our minimum? Remember, we always start domain range with the lowest value, so negative 9 is less than or equal to y, which is less than or equal to negative 1. Is this a function? You betcha. And you're going to see a lot of it in years to come. Now, these guys have, this is t for domain, h for range. So t goes from 0 to 8. 0 less than or equal to t, less than or equal to 8. Range from 0, remember we start low, so from 0 to 5. And that'll be the h's. 0 less than or equal to h, less than or equal to 5, and it is a function. This is not a function, since two values of the domain. And now, in this case, domain has three discrete values, 0, 15, and 30. So let's write it as a set, 0, 15, 30. And the range has 1, 2, 3, 4 values. And they are 10, 20, 40, and 50. A relation is given by the following set of ordered pairs. If the relation is not a function, then x could be negative 5, negative 2, or 1. So there is a possible value of x. There's another possible value of x. There's another possible value of x. If the relation represents a linear function, Then we have to say, okay, what's happening? If I go up by 3, the y values go down by 2. If I go up by 3, the y values go down by 2. So how many down by 2's do I have to do to get to 0? So I'll have to go to 6, to 4, to 2, to 0. So I'll have to go down once, twice, 3, 4 times. I'll have to go down 4 times. So that means this will have to go up by 3. 1, 2, 3, 4. So it'll go to 4, to 7, to 10, to 13. So the value of x is 13. For the linear graph shown to the right, state the domain and range. Domain, oh well, we don't need to be that formal, right? The domain is from 0 to 7.5. 0 less than or equal to t because of the variable. And the range goes from 600 down to 0, less than or equal to capital D, less than or equal to 600. State the rate of change, including units. So the rate of change, what's happening, we're going, pick 2 points. You can see these are obviously points. So we go 200 kilometers in 2.5 hours. And in this case, we go 200 kilometers in 2.5 hours. Now, that's a little awkward to divide by. So let's say we go from 600 to 200, we go 400 kilometers in 5 hours. So that's equal to 80 kilometers per hour. That's the rate of change, right? 80 kilometers per hour. Describe what the rate of change represents in words. Well, it's a speed of 80 kilometers per hour, right? We've got distance divided by time, which gives us speed. Sketch the graph, y equals negative 3x plus 5 by completing a table of values. So I showed you that fancy way of doing it on your calculator. This is fairly simple, so we probably don't need to do that. So negative 3 times negative 1 is 3, plus 5 is 8. Negative 3 times 0 is 0, plus 5. Negative 3 is negative 3 plus 5 will be 2. Negative 6 plus 5 is negative 1, and negative 9 plus 5 is negative 4. Now we want to sketch that. So negative 1, 8. 0, 5. 1, 2. 2, negative 1, and 3, negative 4. Is this a function? Yes. Every element of the domain is associated with exactly one element of the range. Is this relation a linear function? Yes. Every change of 1 in the domain is associated with a change of negative 3 in the range. And that's it for the review, which does not mean that this is all you're going to see on the test, but certainly, if you've gotten through this part, you've seen a good overview of everything, and you need to delve a little bit more into the details, do the review questions out of the book, and make sure that you have done all of the questions in the book.